Morning, everybody. So as Scott mentioned, really huge thanks to everyone for making it here through the weather. I know we've had some casualties and people who didn't make it, and so I'm just really appreciative for you all to be here and to be learning a little bit about blockchain this morning. So as Scott mentioned, I just finished a few months of talking with a lot of these industry leaders, both on the utility side, startups, consulting companies, and today I want to share some high-level blockchain 101 for those of you who may not be as familiar with the technology, and then what's really been happening in the energy market with blockchain to date. There's more detail in the report. Happy to talk to anyone about that afterwards. But to start, why are we all here? Why did we decide to host this conference, and why did you all decide to come? There's been a lot of momentum in the energy sector around blockchain. So we've seen over $300 million invested in the past year alone in blockchain and energy companies. GTM research has identified over 120 companies in the space, and I can tell you more companies have been added in the past week already that I've found. And there's 40 projects happening globally that are publicly announced. I will say there are definitely more when you start including things that people aren't talking about. So just before we get started here, can I have a raise of hands of who is, let's start with on the expert side. So who works at a company where you're either developing blockchain or implementing a project? OK, so we have a decent number of you. And who's never read a project about blockchain your company sent you here? Do we have any of those people? A couple. We have a couple. OK, and so the rest of you are somewhere in between, right? Maybe you've heard of Bitcoin. Maybe you have read some blockchain papers. Maybe you're trying to figure it out. And so I'm going to try to get us sort of on a level playing field. I'm not going to get into technical specifics too much, but just so we can have the same language today. So blockchain is a distributed ledger technology that processes and stores transactions. So what does that really mean? It means that we're replacing centralized legacy infrastructure where one company or maybe a group of companies held the data. And we're making that into a system where everyone can sort of hold the same shared database and co-edit. And so I like to think of it as a little bit like a Google Doc versus a Microsoft Word document. You can edit it at the same time. You can see what everyone else has done. So it's both traceable and efficient, more efficient than sending documents back and forth. Now, of course, it's not exactly the same as Google Docs. Google Docs don't necessarily have that security, right? So anyone can go in if they have access and change a Google Doc, whereas this requires identity verification through encryption, and that's sort of the other factor of blockchain. But so in doing this, we hope to create something that is more efficient, secure, and traceable. And so I think it's best to start with an example. So I'm going to walk through the typical peer-to-peer trading use case, right? We hear about this a lot in the energy sector. So let's take our good friends Alice and Bob from computer programming. A lot of people here recognize these names. So Bob has solar on his house, and Alice is his neighbor. She doesn't have solar. Maybe she can't afford it. Maybe her roof shading isn't good. But so they want to be able to transact on this grid. And to do so, they're going to enter preferences into their mobile application, right? Bob's going to say, this is when I want to sell my solar. Maybe it's when the sun is shining and I have excess. And Alice is going to say, I really like clean energy, and maybe I'm willing to pay a little bit more for local. And so they'll set these preferences, and these preferences will be stored in what's called a smart contract, which is essentially just a piece of computer code that gets enabled with the blockchain. And so when the sun is shining and Bob has excess solar, both of their contracts are going to say, oh, look, I have excess solar. Let me find a buyer. And the buyer side is going to say, oh, someone's selling local energy. I prioritize that. I want to purchase it. So when this transaction gets announced, it has to be verified, right? We have to verify that Bob actually has the solar and that Alice actually wants to purchase it. So this validation process is often called mining. So the miner is the validator, and we have our miner here. And essentially what they're doing is solving a complex mathematical problem that is verifying the person's identity. The person's identity is encrypted, and this is sort of the mathematical way of doing it. I'm not going to go into the mathematics today. I think it just suffices to say that happens when someone finds a solution and they verify that that's the person. They tell everyone else in the network who's also doing the verifications the solution so that everyone can say, yep, we agree. This is Bob and Alice. This is the smart contract they have. We're going to verify this transaction. That transaction is incorporated into a group of transactions known as a block of transactions, which is then attached to the previous block of transactions, creating a chain of blocks. And there you have it, blockchain. We're done. Conference over. No, so then Bob gets paid, Alice gets her power, and everyone's happy. And there you have it. Now we all understand how it works, right? So I think today there's sort of 4 key areas that I want us to all be able to talk a little bit about and understand moving forward. So the first one is consensus protocols. So when thinking about how these transactions are verified, there's actually, again, this is a peer-to-peer network, so you need to have people agree that a transaction is true. The most commonly discussed one, proof of work, which I will get into, is actually not used very often in energy because it's also the one you hear about a lot for it being energy intensive. When everyone's saying Bitcoin's using as much energy as Ireland, right? They're talking about the proof of work consensus mechanism, and for that reason, it's often not used in the energy industry. So the way proof of work works, just so we understand, is let's say I'm trying to send Scott over here $10. The normal system, I might go to my bank, and they would verify that I have $10 in my account. And then they might go, and then they would go verify that Scott has an account with another bank, and then this transaction would happen. Maybe I'd pay some fees. So what if instead you guys were all part of this peer-to-peer network? And I just announced, I'd like to send Scott $10. And everyone can see, everyone has this shared database, right? And so you can see that I have $10, and you can say, great, I can see Scott's over here, and then you just send it to him. That's essentially how blockchain proof of work is thinking about it, except that the first person to verify that I'm me gets paid. And so you're all competing for it. So imagine that everyone's sort of like in their, everyone is at their computer trying to solve this complex mathematical thing. You have increasingly difficult amounts of computational power that's needed to be first. And so that is why you get this really high energy consumption, because as the price goes up, your ability, your desire to be first in terms of processing power increases. In proof of stake, we still have that same announcement, but instead of everyone competing to find the solution, someone's selected. And that selection process happens based on a probability of how much of the currency within that network works. So Ethereum is which is a blockchain network, is trying to move to this. So let's say I have 3 Ether, which is the currency in Ethereum, and this gentleman in front of me has 1 Ether. I'm 3 times as likely to be chosen to validate the transaction as he is, and if I get chosen to validate the transaction, I'll get the transaction fees. Now, if I try to falsify that transaction, my 3 Ether are essentially in escrow, and they'll be deleted, and I'll lose that. So I have a disincentive to try and cheat the system. In proof of authority, which is what we're seeing most frequently in the energy industry, it's actually a bit more of a centralized system than what blockchain was previously done. So you'll notice here that permission level is permissioned. I'll get to that in the next slide. Essentially, a consortia come together and choose who the authorities are. And so with the Energy Web Foundation, which probably a lot of people in this room have heard of, they have a consortia of 37 companies, a lot of which are utilities, and they're actually the ones doing the validation process. And so it's saying we have some trust in these higher level organizations, and we think that it will be more efficient to have them do the verification because it'll be faster and less energy intensive. So moving to these permission versus permissionless, there are some trade-offs here. So in permissionless systems, you do have this sort of truly decentralized state, but it can be kind of inefficient because you need everyone to do the verification. On the permission side, however, not every node needs to verify. And so while everyone can participate, you also sort of have this ability to be faster, also enable certain permissions on data sharing. Again, in the energy sector, it's highly regulated. We care a lot about who sees our data and how they see our data, and so permission sides enable you to control that a little bit more. So again, even in instances of energy where people are using the Ethereum network, it's often a permissioned version of the Ethereum network. So tokens. I want to start off with saying that tokens are actually not, or coins, or cryptocurrency. You may have heard all these different terms. They're not necessarily required for blockchain. There are blockchain energy companies that are working without them, where they're really just working on trading data and that cooperation level that blockchain enables. But I do want to go over the sort of 3 types of coins here. So there's native, intrinsic, and built-in tokens, which are sort of can often be your cryptocurrency with like a Bitcoin, or within Ethereum, it's called your sort of crypto fuel. It's the coins that's used for the transaction layer, and it's sort of the incentive for verifying transactions. In other cases, this third one is Power Ledger, which is doing a lot of peer-to-peer energy trading. And their power token gives you access to the platform. So you need to buy it in order to be part of the group. But once you're within the group, you actually use an application token, which is called a Spark, that's tied to the local currency. So application tokens are things that are going to be built in the application layer. And you can think of it as more of a representation of something in the real world, from the sense that it could be equal to a kilowatt hour or to your local currency. Because again, if I'm buying and selling power through blockchain as a consumer, I probably don't want to be subject to the volatility of another currency, right? I want to be paying in US dollars. And so these application tokens enable you to do that. The third are asset-backed tokens. So those are things that are tied to physical assets. So I could crowdfund a solar panel, and I could own 1 kilowatt of that solar panel. And this coin would be equal to a kilowatt. The final thing I want to get through is smart contracts. So smart contracts allow you to agree on future transactions. They're just computer code. They sound really fancy, but they could be as simple as this really simplistic, if it's less than this price, then buy it, otherwise buy your grid power. Users are often interacting with these via applications, so on their phone or on a computer. These smart contracts are stored within the blockchain, and what's important about them is that they self-execute when conditions are met, right? So going back to the Bob and Alice example, Bob doesn't have to sit there and say, oh, great, I have excess solar. Let me go look at the list of buyers and choose who's going to buy this. Both of their contracts will settle that instantaneously on their own. So I know that was a lot. For those of you who know blockchain, you're probably like, yep, got it. For those of you who don't, it's probably still new. I highly recommend diving deeper into that. And I'm happy to talk with anyone about specific questions you have, and hopefully have time for questions at the end. But I want to get into what we're actually here to talk about, which is blockchain energy. So there's sort of 3 factors that make energy ripe for blockchain adoption, right? So there's a lot of intermediaries in the space. Blockchain, you often think about increasing communication layers, potentially disintermediating industries. So everywhere from wholesale trading markets, right? You have your large-scale power, you have your utilities, all of the vendors that they're working with and the work they're doing, your consumers, your prosumers, right? There's all these different players in the market. And so getting them to be able to share data more efficiently is definitely something that people are working on without blockchain, and blockchain could help enable. Second is slow financial settlement times, right? So thinking just utility billing as an example, right? I don't get billed for my data or for my energy usage until a month after I've used it. Increasing those efficiencies could help companies with their liquidity. And then finally, increasing decentralization of the grid, right? This is the big one. The rise of distributed resources and Internet of Things devices is really leading to this area where we have a lot of decision making that's happening at the grid edge. And doesn't it also make sense for there to be distributed computing at the grid edge? And so I think, again, there are other forms of distributed computing beyond blockchain, but blockchain is one of those really big enablers. So we identified 18 large use cases that are driving this adoption that we're seeing people use in the market. The majority under development are in transactive energy, so everything from your peer-to-peer trading to EV charging, demand response, really anything where the consumer is providing grid services, engaging with the grid, getting monetary value from that. We're also seeing areas in accounting, so from your retail billing, your sort of renewable energy credits, other certificates of origin, asset registries. There's your more crypto-related types of use cases, which is going to be your crowdfunding of renewable energy assets, looking at, again, back to that proof of work being energy intensive, your sort of clean energy mining, so building renewable power plants just so you can do clean mining. And then, too far. And then cybersecurity. So again, as we're getting all of these extra devices on the grid, there's both questions of how do you trust that signals are coming from who you think they're coming from, and also just last night I was reading about how the Alexas are randomly laughing at people, and there's a concern that it actually might be malware that's within these devices. And so I think there's this big question of, yeah, your Alexas are laughing unprompted. It's terrifying. And so there's a big question of, is my Alexa taking over the world, or is it malware? And both are pretty terrifying options there. So that's a really big concern. And so I guess blockchain can help with that as well. And so I do want to sort of bring it back to, I just mentioned a lot of use cases. All of them could have a whole hour presentation on them alone. I think it's important when we think about blockchain to think about what it is and what it isn't, because a lot of what the blockchain and energy companies are doing is much beyond blockchain. I think they should also be getting credit for what they're doing beyond blockchain as well. Blockchain enables the settlement and data transfer layer, right? It allows communication across parties. It allows data transfer. It allows you to store these smart contracts. But you still have to interact with the physical energy world. And you still often have these analytics platforms on top of the blockchain layer that are going to be doing this optimization process, right? You're still going to be interacting with your distributed energy resource management systems or with your outage management systems. And blockchain's there to help do that settlement as an extra layer. So just as something, so I think a lot of times people are like, blockchain is magic. And it's IT infrastructure, which it can be magical, right? But is still a real thing that we can talk about today. So I want to talk a little bit about the projects that are going on. So we've identified 40 deployed and 33 planned public demonstration pilots and projects globally. I will say, like Chile just announced last week that their Energy Regulatory Commission is going to start using blockchain. There are other projects in South America and Africa that I know of that are not public yet. So there's more here to come. But you'll notice the two big, Europe is the big player. Germany and the Netherlands are overlapping in this chart because they're just too big and too small countries. And then the US, because we're here today, I want to sort of highlight a couple of the projects that go beyond peer-to-peer trading in Europe and the US. So in Europe, one of the interesting projects I think we've seen that brings across this idea of interoperability is the Oslo to Rome pilots with MotionWorks share and charge product. And so what they've done there is they've tested the ability to use a blockchain charging app across countries throughout Europe to charge at EV charging stations by different customers. And so they had 7 industry partners there. And that's been a really interesting pilot to follow and sort of see how we use blockchain to enhance interoperability. Wholesale trading, so that's one of the areas where I think we've seen a lot of development and are closer to a commercial product than a lot of other areas. So Ponton is working with 39 companies across Europe to do wholesale trading. They've been doing pilots. I think that ends in April, and they're thinking about launching a commercial product this year. On the grid flexibility side, we have transition system operator Tenet is working with Sonnen and IBM to manage residential storage systems via blockchain, and to also use blockchain to also not just help call the system and see what flexibility is available, but to also verify that the storage system actually acted as you expected it to. In the US side, so I study microgrids when I'm not doing blockchain, so I had to throw a microgrid one in here. Omega Grid has been operating their blockchain on site at the Stone Edge microgrid at a winery to do calculations on optimal power flow and help maintain stability within that microgrid. And then on the cybersecurity side, again, I think it's something that's increasingly important for utilities across the globe. So US Department of Energy has actually contracted with several industry partners to look into how blockchain can help with cybersecurity on the grid. And the fact that the US government is looking into it and taking it seriously, I think, is really interesting. So we talked about some of the projects. So who are these companies that are doing this? I mentioned there are 122 companies. Here they are. I know this is super overwhelming, so don't get scared. I'm not going through all of these companies right now. But what I want to highlight is sort of this top layer here, right? When we think about who's building these applications and where they're falling. You have some companies that are just focused on application development. You have others that are also trying to build that sort of platform infrastructure below that. And then you have some that are also trying to build the blockchain infrastructure below that. And so what I mean by that is there's companies that are focusing on what the platform is and then building and allowing potentially other companies to come in and build applications on top of that platform. And then the infrastructure is going to be sort of the core, what do we want this blockchain to do, and what permissions, what consensus mechanisms is it using? So of these 122 organizations, 94 are working on application development. And the majority of those are focusing on transactive energy. So I think, sort of bring this back to sort of the grid edge, transactive energy is where we see a lot of this work going on and continuing. And we're seeing a lot of movement in peer-to-peer side, but we actually think that it's exciting, and a lot of people are doing it because of that. But we're going to see a lot more movement probably first on the demand response side, on the EV charging side, places where there aren't as many regulatory barriers, where there aren't as many technical barriers to start. So there's 122 companies. How are all these companies affording to be working in this space? I think one of the important things to note is that 75% of the money that's been raised so far has been initial coin offerings. For those of you that aren't familiar with that term, it's a blockchain-specific way of raising money where essentially you mint new tokens, the tokens that we were talking about earlier, and you sell them. And then you get lots of money. And some companies have minimum viable products and projects in the ground and have used this as a really effective tool of fundraising. There are also quite a few companies that have a white paper with no projects in the ground, no minimum viable product, and they're also raising in sometimes millions of dollars. And so it's going to be interesting to see how this shakes out and what these companies are able to do with this money. So ICOs have ranged from $150,000 for a company up to over $100 million for a company. I will mention that company is a clean energy mining company, so it's a bit of a different animal here. But we still have multiple in the $30 million range. And these are the prices. I should note here that these are the prices based on a lot of these companies raise in cryptocurrencies. I do the conversions the date that the ICO ends. Anyone in Q3 2017, if they kept most of their money in crypto, they've made a lot more money since then because the prices have been rising so steadily. So we're not seeing an end to the ICO hype yet. There's a lot of companies. I would say there's been a bit of a pivot. A lot of companies are doing larger sort of token sales to institutional investors only, rather than these sort of large crowd sale grabs. But we have quite a few in Q1 2018, right, over double what we saw in Q4. And Q2 of this year, we already have 7 projects announced. So there's a lot of funding to be happening in this space continuing. I don't want to leave the utilities out of it. So utilities are working in this space. This slide only shows direct investment to companies rather than consortium or products. So Centrica, Innogy, and TEPCO have really sort of been driving the direct investment side. But there's consortium. The Energy Web Foundation, as I mentioned, has 37 partners, many of which are utilities. Electron has a consortium that has National Grid, as well as some DNOs in the UK. And there's also Ethereum has a consortium and energy working group, as does Hyperledger. And so there are definitely a lot of utilities are putting, more than this, are putting money in the space. But these are sort of the ones who have directly invested. And I think that we'll see a lot more of that and a lot more consortium building over the coming years as well. So looking forward, I'm excited to hear from all of you today about what's happening in the space, what you're excited about, what your reservations are. There's a few questions that I sort of have moving forward in this space. The first one is around business model. So I think there's still a lot of question on how these application developers make returns, whether they're the new middlemen that they're trying to disintermediate. And if so, how are they more efficient and cheaper? Or which are they? Are they maybe more expensive but vastly improving efficiencies? Or are they a lot cheaper and around the same? And I think that's going to depend on the use case and the application, the implementation. But I'm excited to talk more about that because I think there's a tendency for people to just say blockchain is more secure and efficient rather than talking through the specifics of that. On the security side, how does it actually increase security on the grid? A lot of times when you think of how you interact with blockchain, in the crypto world, in a lot of worlds, you get a 26-digit alphanumeric code, right? People are putting them as safety deposit boxes. That's not how the regular consumer is going to deal with it. When you start thinking about that, how does that affect security? If I suddenly have a password that's linked to my blockchain, does it inherently reduce the security? Or are you building the blockchain into a device, which some companies are doing? So I don't even have to have a password or know any code. It's just there in the device, which would be more secure. So, and then who owns the customer data, right? There's a lot of talk about utilities have a lot of power because they own data. In these new systems, the consumers are going to own the data. Is that true? And if so, how does that change the dynamics of how the system works? On the interoperability side, there's both interoperability of how blockchain is working with legacy utility systems, as well as how different blockchains interact. We're seeing some movement on blockchain-to-blockchain communication and interoperability, because we're not all going to end up on the same blockchain, and it's going to have to be a question of how you communicate across these barriers. And then finally, our favorite word in energy regulation. So blockchain sits in an interesting space because it's right in the middle of your financial and your energy regulations, right? The two of the most heavily regulated industries. And on the electricity market side, what needs to happen to enable this future that we're all envisioning and we're excited about and we're here talking about? And I think, again, the answer with a lot of that is that it's not necessarily regulation around blockchain, but it's regulation around the use cases that you want to use for blockchain. And then on the blockchain side, there's been a lot of questions in the US around SEC regulation, right? They just subpoenaed a bunch of ICO, not in the energy industry, but can you do ICOs in the US? And how can you do that without either calling yourself a security or moving in a different direction? Anyway, so those are some of the questions I have. I'm excited to hear people's answers today, and thank you. Yeah, so
we can take some questions.
Yeah, I believe we have like a couple minutes for questions.
Yeah, sure.
I don't know if
Let me see if there's someone here, or someone can shout out if you.
Yeah. Oh, okay. I'm back on.
In the microgrid project, what is different or unique compared to other microgrids not using blockchain?
Not using, OK. Well, I might put Killian on the spot later to answer this question in his panel. So I think what's interesting there is that it's doing it a lot of times on economics. And obviously within a microgrid, you aren't necessarily going to have to, well, I shouldn't say that. Within this microgrid, you don't have to pay your other assets because it's the same owner. But if you imagine a microgrid where you had multiple owners, you could do the financial settlement without a utility there. And it also enables you to, I guess, from the controller side, I know that there is also a controller there on site, but it enables the coordination across assets and to deal with congestion on a distributed level. So hopefully to do faster processing.
Is the pivot of token sales to institutional investors a response to increased scrutiny and likely future regulation from the SEC? I'm not sure the pivot has actually occurred yet, but
I think you're definitely starting to see people thinking more about going to institutional investors or doing token sales that are only to institutional investors. That's also happening as well. And yeah, I think that's largely around regulation. I think people will continue doing ICOs in the traditional sense while they can make money. And again, a lot of the energy ones have already restricted US people from buying. So there are a lot of ICOs that just exclude the US because they think the US is where the biggest problems are. And so I think from a US perspective, that actually leads to potentially an earlier pivot towards more traditional forms of financing.
Okay. My utility already allows my neighbor to use my excess solar generation when I'm not using it. Why do we need transactive energy in the way you've described it, the new middleman?
Right, so that's a good question. I think that's a real question in the sense of in places where there's net metering and you're getting the full retail rate, unless you have local consumers who are willing to pay more for local energy, there's probably not a lot of a need. You could imagine a place potentially where when you have net metering below the retail rate, or maybe that sort of ceases to exist, where there might be an arbitrage opportunity to be able to have your local, someone local be able to pay, still lower than the retail rate, but still higher than what you would get for net metering. But I think that's why we don't see peer-to-peer as sort of one of the future things, because a lot of times it really is just more of an accounting mechanism than an actual physical trade that's happening.
Right. Of the $324 million invested, how much in the form of ICOs? I think you said 75%.
Yeah, it's 75%.
Okay.
Or ICOs.
If transactive energy is the major use case, aren't there many good ways to provide the ledger and security identity already?
So yes, and I think that's the good question on blockchain is always why blockchain. And I would argue to ask every person you meet this, because every time I ask, I get different questions. But I think blockchain it's the immutable aspect of the ledger, not being able to transition beforehand. It's the increased security using encryption. Blockchain brings together a lot of legacy technologies into one. And so I think, again, that's something to remember, and this is part of why we're here, is to talk about what blockchain can do and what it's exciting, but also to remember that this is a consortium of ideas that have been around a long time and are being put together in an innovative way.
Okay.
All right, I think.
Actually, one just popped in. It's kind of an interesting clarification. In the peer-to-peer case, wouldn't this require that the utility provide you a bill credit against your peer-to-peer transaction? What's the advantage? That was.
I think that will get.
It always needs a little bit of explaining. Is like, if you're doing peer-to-peer transactions, what does your utility bill look like at the end of it versus the settlement with?
Yeah, and I think that depends a lot, right? So I think with some peer-to-peer right now, the blockchain player is becoming the retailer. So they're actually sending the bills, and they're including the T&D on it. In other cases, yeah, I think that's an open question. I think there's lots of ways you could do it, right? You could say, I'm trading the electricity, but then you have to figure out how to get the T&D rates in there as well. So maybe you're just trading the premiums.
Okay.
That's a possibility as well. But I think we're seeing, most of what I've seen to date has been the blockchain company for now becoming the retailer, and that's largely because you can't usually legally actually trade with your neighbor yet due to regulations. And so generally your smart contract is you trading to the blockchain company, and the blockchain company selling to your neighbor. And I don't think that's how blockchain companies want it to be in the future, and I will happily have someone counter me on how they're doing it in a more innovative way, but that's from who I've spoken with, how it's happening right now.